Hey guys, welcome back to the channel. I thought we'd do something very interesting today. I am going to talk about 3D printing. So what I'm going to do is talk you through a project from start to finish. So what we're going to do is I'm going to build a box like this, that with one going inside the other. And we're going to make that for this remote and this remote. We're going to actually just have both of these sitting inside the box. So we're going to make the box just barely big enough to hold both of those remotes. So first what we'll do is I'm going to load up my Fusion 360. This is the program I use to develop the 3D geometry. There's other ways to 3D print things. You can go to Thingiverse. That is a website where you can download 3D print files. You can also go to a website called Thangs. That includes Thingiverse, but it includes some other websites. That's for looking for projects that are already created that you can use on your 3D printer. So we'll wait for my Fusion 360 to boot up. It takes about 60 seconds on my old laptop here to boot up. So here I've fast forwarded for you. Okay, so this is Autodesk Fusion 360. It is a fantastic software. It is available free as a trial for, I think, 6 months. And then it's only a couple of $100 per year or something like that. So first we're going to do, so we have a blank project here. We're going to turn on the origin. So now this is just viewing our three-dimensional space. The entire way this works is through sketches. So we're going to create a sketch. And we're then going to pick a plane. And I always like to pick this bottom plane. And then when I click there, it will line that up. We're lining up with the camera facing directly down on that surface. So as we're building this box, we have to think about how we're going to 3D print it, okay? If we print it like this, with that being the surface, and then it lays the plastic with the opening like that, we're not going to have a problem. If we were to try to 3D print it with this on the bottom surface, then they would have we would need to print support or something to hold that up while it prints. So the preferred way to print it will be with the solid surface down and the opening on top. So that with that in mind, this initial surface is the surface that we're using on the print bed. So here what we're going to do is we're going to grab a rectangle, a 2-point rectangle. We'll just start here and draw a rectangle. After you draw it, you can see that there's black lines and blue lines. The blue lines mean that it does not know the dimension. So what we'll do is go to dimension. So I hit D to dimension, and you can see how the cursor changes. It looks like the lines with the two arrows. So now I can say, okay, this dimension, and as I click a line, now it's giving me a dimension. Right now it's 132, this is millimeters, but let's measure this remote. So this will be the long dimension of the remote, and I have my calipers here that go to 150. It's bigger than 150. So I'm measuring my remote. So it's 150 plus 25. And the beauty of this software is I can actually say, so after I click that down, now it's asking for the number. So I can say 150 plus 25, but we also want to give a little bit of an air gap all the way around so we can get our fingers in there to grab the remote out of the box. So let's give it an additional 15 millimeters. Okay, so now I've got 190 millimeters in that dimension. Now I'm going to just drag this over so we can see what we're doing. So that's the remote on the long axis, and that's going to be the one length of the box. In the other dimension, we're going to have the remote, which is 45 wide. So let's click a dimension here. We're going to dimension this line and click that so that this remote is 45 plus about 58 plus, again, let's give it maybe 20 millimeters of extra space to get your fingers in and get them out of there. Okay, so that's 123. So we've drawn a rectangle that's 190 by 123. And now we're done with that sketch. That is going to be the internal dimensions of the box. But actually, let's do one more thing before we do. When we draw that's going to be the bottom of the box. Let's make that the internal dimensions. So now let's get another rectangle. And we're going to draw a rectangle just outside our initial rectangle. And I'm going to, I hit escape to just throw off that rectangle. Now I'm going to drag these dimensions. I'm going to drag these dimensions inside so we don't get confused. There we go. So now I've got the dimensions inside. Now I'm going to dimension the outside. So the best way to dimension this, since I want to just define the thickness of the box, I'm going to hit D to dimension. So I'll hit this line and that line. Now I've got a dimension between the two. Right now it's 9, but let's say we'll make the thickness of our box 4 millimeters. Okay, so now that's 4 millimeters. Now I can dimension this width here, and it is initially defined as 10, but I can actually float over the number 4, and I can say same as that other one. So now it's going to be the same as the other dimension. So now we'll do that on the bottom edge. Click the one, click the other dimensions between the two. That's initially 13, but again, we can say, let's actually make it the same as this dimension. And on the left side, click both to create a dimension between the two, and again, make it the same. The beauty of doing it that way is if I were to double click here to alter this dimension, let's make this one 10, it actually changes all those ones that are referenced. But let's change it back to 4 millimeters. So when you want to make that change, you double click the dimension, then you can put in a different number, enter applies that. And here, let's put it back to 4 millimeters. So we have the internal rectangle will be the inside box dimension. The thickness or the outside rectangle will be the outside of the box dimension. So now we're done with the sketch. We'll hit Finish Sketch, and it puts us back in this three-dimensional view. Here we have a way to navigate the shape. So we just hit the Home button. It'll just center it up on our screen. So currently we just have a two-dimensional drawing with two rectangles. Now we are going to try to create that, elevate that into 3 dimensions. So we hit the Q, which is press pull. We're going to take these shapes and push them in a perpendicular direction to create a thickness. And again, we made the walls 4 millimeters thick. So let's select this, the center, and let's type 4 to make that 4 millimeters thick. And there's the bottom of the box. I hit OK. And now, because we use that sketch, it turns it off, but I can go over here to this panel on the left, hit the triangle, and we can see sketch 1. Let's turn that back on so we can use that again, because again, now I'm going to hit Q, which is press pull. We're going to select this outer rectangle, and you can see it turn blue. Now we're going to select how high that box goes. Well, this remote is skinny, and this remote is fatter, so let's do the thickness of this remote plus a little bit. So we're measuring that distance. That's 25. So let's make this, let's make it 30. And we hit enter, and there it is. You can still see our sketch down below. Let's turn that back off. Okay, so now we have our box. Let's center it up on our screen by hitting the home, and we can navigate around, and you can see it's three-dimensional. It has a bottom and the 4 sides. Okay, now let's just center it up. So the other thing to do before we pass this now from Fusion 360, we're going to pass this to Cura Slicer. The Slicer software will take the three-dimensional object and decide how to print it and create instructions for the 3D printer. Before I do that though, there's a lot of sharp edges on this. You can see the corners of the box are perfectly sharp and everything's perfectly sharp. So what we can do is create some fillets. That's kind of a rounded edges. So let's do that. Let's just select the bottom. And then I hold down on my Mac, hold down the command button. I can select multiple objects and I'm going to select as many as I can. Then we're going to rotate the body and I'm going to select these other three on the opposite side. So I've basically selected I think I've selected every surface that I can get to. I'm going to take that back. I got to select these two here and there. So basically I've selected all the surfaces except for this top, but it will still work because as long as one of those corners is selected. So now I'm going to hit F for fillet. And we're going to make that, let's make that 1.5 millimeter. And now you can see, if you look closely as we zoom in, it's actually rounded these edges. And you can see very much a rounded edges on that box. Okay, so that makes it a little smoother, makes it less sharp, and you're going to get less 3D printer kind of artifact problems. So this is what we're going to export to the 3D printer. Before I do that, let me show you how I would make the lid. Let's back off. This is the fillet. On the bottom is all the steps you just did. And so what I can do is I can say before the fillet, so we back up one step, and I would say, okay, let's make another sketch. Again, it's all about sketches. So let's make another sketch. Let's make the sketch on this top surface, this top edge of the open box. Now I've got that edge. Let's move this into position so we can see what we're doing. So what I would do here is design put a rectangle for the inner surface of the lid, and then I would make another rectangle for the outer surface of the lid. Then we would dimension these. I would say, let's make this a 1 millimeter gap between the inner box and outer box. And then let's make the outer box, again, the wall of the outer box will be 4 millimeter thickness. Let's get that dimension one more time. Just drag that out here. So see, I've created a gap, an air gap there between the lower part of the box and the lid of 1 millimeter, and then I've made the wall thickness 4 millimeters. So if we do this here, and again, we'll say instead of putting a new number, let's just reference the previous dimension. And here, the thickness of the wall, let's reference this previous dimension. So from the outer surface of the lower box to the inner surface of the upper box, let's make it, again, reference this measurement, which is 1 millimeter. And then we'll dimension from the thickness of the upper box, again, reference the previous dimension. Same here, measure these, create a dimension, reference this one. One more dimension here, and we'll reference that one. So now I've created the sketch in the plane of the upper surface of the box, and we will finish that sketch. So now I will use my Q, which is my press pole, and I will make, so this is a little tricky. What we'll have to do is we want to select the inside and the outside and the air gap and the outer. So we're choosing everything, including all the way to the outside. And we're going to go, again, 4 millimeters. And that worked correctly. It went 4 millimeters up. So from the previous surface, it went 4 millimeters upward. If we went minus 4 millimeters, it would go downward, and we're going into the other box. Now you can see here, we get to decide on the operation too. Right now, because we're hitting another object, it wants to cut it. But as we change it back to +4, it created a, let's see, think I accidentally did something wrong there. So let's select those again. So as I zoom in here, we're going to hit Q for press pull, and we're going to select all 4 of these so we have all of the rectangles. Then we're going to select a distance of 4 millimeters. That goes upward. Now we don't want it to join, we actually want it to create a new body. And when we create a new body, now that does not join it to the previous. And you can see now it's got, in terms of bodies here on the left, I've got body 1, which is the bottom, and I can turn that on and off. And I've got body 2, which is so far the lid, and I can turn that on and off. So what we want to do though is turn the second sketch is our sketch of our top. Turn that back on, and we'll rotate that so we can see what we're doing. Zoom in a bit. Zoom in a bit here, and we want to do Q, which is press pull, and we'll pick just that outer geometry, not the air gap and not the inner. And we're going to make a new body. We're going to make that distance. The previous was 30. Let's make this 25, just slightly. Okay, so now it's gone the wrong. No, I've given 250 instead. Let's see, 25. Okay, and it's going the wrong direction, but we just put a negative there. Now we're going the correct direction because it's going down to close the box. We're going to say join, but before we do join, let's turn the first body off so it doesn't try to join with the bottom, but it'll just join with the top. And so now we're joining, and there we go. Now that's created. Let's turn our sketch off so we can see what we're doing, and go back to the default. And now you can see that's the lid. And as we rotate, it's not solid, it's actually the lid. And let's do that again where we, let's select all these surfaces. Yeah, and let's do a fillet F of 1.5 millimeters. And there we go. Now we've got the lid, and if you look closely, it's actually going to have all the rounded edges, which is nice, and that's what we want. So when we print this piece, we'll have to print starting with this face touching the print bed, and when we print the bottom the same way. And then this, if we were to print with this surface touching, we would have to print some support under here, and we can talk through a little bit of that later. So now we've created our geometry. That's the lid though. Let's not print the lid, let's print the bottom. So this is the bottom. And let's go ahead and turn on our fillet again for the bottom. Okay, so this is the bottom, and you can see it's got all its fillets, it's got its rounded edges. So now we are done. So now we are going to save this file. Let's call it remote ×2 box. Save that as a project, but we're also now, in order for the Cura Slicer to see this file, to use this properly, we will have to go to export. We're going to export this as a STL file. The STL just exports the three-dimensional geometry. Now, since I turned off, and we're going to export, and it'll bring up this other thing, it'll take a minute to do that. Since I turned off body 2 and turned on only body 1, which is the base, so we can actually rename these bottom and lid. So I've turned on the bottom and I left off the lid, so when I export that, it just exports just the part that's visible. So it's just going to export the bottom. And now let's check on our job status. Okay, so this is still working. So we'll give this a minute to export. In the meantime, let's boot up our Ultimaker Cura. This is called the Slicer. This will take the three-dimensional STL file and we'll slice it apart with our settings and create instructions for the 3D printer. In other words, it'll say, 3D printer, move here, extrude or spit out plastic, and then move from here to there, and then spit out plastic here, and then stop printing and move over here, and all the specific values and all the specific instructions for the 3D printer to follow, including the temperature and all that kind of stuff. So we'll skip that. Update. Let's see if Okay, so this is complete. The export's complete. Now we'll go to our Cura Slicer. We are going to open that file, and by default I've got it set to the same as where the output one goes, and there it is, remote ×2 box. And this is the three-dimensional geometry file called an STL file. Okay, so let's open that one. And this has opened properly, and it's almost as big as my printer can print. And you can see, as I rotate it around, it has that geometry put on there. So this is the origin of the printer. This is the far right back of my printer. I'm usually standing here in the camera. The camera for the time-lapse will be from here, shooting this way. So there's the box. If we needed to rotate it, we could rotate it, right? Let's undo that. If we need to move it, we can drag it around, put it in a different spot. Let's undo that. If we needed to multiply and print more than one, of course this occupies the entire print surface, so I wouldn't be able to print more than one. But this is looking pretty good. You can also, with this software, scale it. You can scale it in one dimension or all dimensions, and you can resize it and change a lot of parameters. Let's undo that. Okay, so now we're back to normal, and I think we're good. So these are the settings. So we'll go to our settings, and you can see first there's a layer height. So this is as it prints, every layer it's going to print is going to be 0.19 millimeter thick. So about every 5 layers is a millimeter. Wall thickness, I'm going to make 4. So it's going to print 4 lines on the outer wall and 4 lines on the inner wall and 4 lines on the wall of the base. Horizontal expansion is a adjustment that makes it print an accurate dimension. So over the last 100 prints I've done, I've dialed that in to print so that our measurements are actually pretty accurate. And so that should print pretty accurately. We don't have to change that. On the top layers, let's make that actually 5 instead of 4. And on the bottom layers, I think we can get away with 4. Infill. So infill is in the space between the solid top and bottom or walls that will infill with something with kind of a pattern. And this is, it selects this cubic pattern. You've got a lot to choose from, but I like the cubic pattern. I set my printing temperature, so this is for the hot end where the plastic's coming out. I also set a build plate temperature. It's a warm day today, so we can take this down just a touch. And speed-wise, that helps things stay accurate, and that's about it. I don't need to generate support. In other words, there's no parts of the part that are overhanging, and I would have to support them as they are printed. And I don't think I need adhesion because that entire top of the box will adhere to the surface. So we're done with that. Let's hit the slice button, and it will compute. And so it's asking if we want to save it, and we will save it. But first, let's take a look at this preview. So the preview will just basically draw how it's going to print this. And if you look very closely, if we zoom in really closely, we can actually see what this is going to print like. Let's just zoom in on a corner so we can see what this is going to print like. As I slide this slider on the right hand of the screen, it shows me what it's doing. But let's zoom in a little closer so we can see what's happening. This is the corner, and as you get close enough, you can actually start to see the real detail of what's going on. So these are basically have traced out the instructions to the 3D printer. So as I slide down the wall, you can see there's one outer wall and then 2, 3. So we've decided to have 4 total. And then there's going to be another 4 here. And then it's going to kind of infill between. So there's quite a bit of infill here at the corner. Almost a little bit of infill there, but not too bad. At the very bottom, as we go all the way down, you'll get a little bit of infill. Now between the inner surface and the outer surface, you'll get all this infill, and this is this cubic pattern that it creates, this cubic pattern. So there's some air gaps in there, so it doesn't use as much plastic. But at the very bottom, we have one layer, one layer, 2 layers, 3 layers, and 4 layers, and then it starts the infill. And then at the top, it should do, right here, it should do 5 layers. 1, 2, 3, 4, 5. And then it starts building the walls. So, and then at the very top, it will start making the walls skinnier and create that rounded edge. And that's the final edge. So it also gives you a time estimate here. It's going to take 13 hours and 9 minutes. So let's save that to disk. We'll hit save to disk. It already is pre-configured for my gCode folder. So gCode is the actual second by second instructions to the printer. So now I've created remote box X2 ×2 box in gCode. Let's save it to my gCode folder. It's saved, and now we're good. Now we will go. Now we'll send it to the printer. So the 3D printer I have hooked up with a Raspberry Pi. It runs a software on the Raspberry Pi called OctoPrint, so I can jump in and control it from my Wi-Fi network. So what I go to is my 3D printer. And here, this is a web browser, so I've got it under my 3D printer. Here it's just loading the user interface, and here, this is the OctoPrint user interface. So what I'm going to do, and that is a code that, or a warning that seems to not create much problem ever since I updated the latest firmware, but it seems to be printing normally. So I'm currently ignoring that. So what we'll do is we'll upload. And you can see it's already pre-configured to end up in the folder, which I often use, where it's all the gCode. So I'll hit the gCode and upload that. You can see the little bar going across, and there it is. Remote ×2 box. And here I would hit the button, it would start printing. So if I hit that button, it will start printing, and you'll see it move here. Print, and immediately it is homing the 3D printer and raising the bed to its home position. So it basically goes to the origin, and then it starts heating up the 3D printer. So you can see on the control there, that is the camera view basically. And under temperature, we have basically relatively cold, but now we've set a bed temperature and we've set a hot end temperature, and you can see they're already starting to heat up and it's starting to get ready to print. So I do like to go and clean my print bed as this warms up for a couple of minutes. I do like to clean the print bed with usually rubbing alcohol on the 3D print bed to get it nice and clean. And so here's a view of the time lapse of it being printed. Remember, this took 13 hours and 9 minutes. So you can see it prints the perimeter, and then it prints a diagonal pattern to fill in that space. This is the bottom surface of the box. The second layer, it prints perpendicular, again a diagonal. The next, again, perpendicular. And this one finally perpendicular to the last. And now we're starting to see the infill. This is all infill, infill, infill. And now we see the first inner layer of the box, very rough. Then perpendicular, you can see it gets a lot smoother. Then the third layer, again perpendicular to the last, and it starts getting very smooth. Then we do a fourth layer, perpendicular to the last. And finally a fifth layer. I think this is the final layer. And now it's just doing walls, 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 walls. So let's speed this up a little bit. And that is it. So here we can remove it from the print bed. And we'll peel it off of this magnetic build surface. Little bit of a defect here because it is a very old magnetic print surface. There is a little warping here on the corners because I don't have a cover over my 3D printer to maintain the temperature for this ABS. So let's test it. We've got the two remotes here, the TV remote and the fan remote. They both fit in the box nicely. There's a little bit of space for them to move around, so they're not too snug. A little bit of space to get your fingers back in and grab them back out of there. Okay, we're back in Fusion 360 here. I'm going to open up my previous design that we just made, remote ×2 box. We are going to turn on, instead of the bottom body, we'll turn that off, and we'll turn on the lid body. Okay, and as you can see, this is the lid. So now let's export this out as an STL file. Okay, so that's complete. So we're going to switch to our Cura Slicer. Now we're in Cura Slicer. We're going to open up that file that we just created. This one, and it says version 2, which really is just the lid. Let's open that up, and here we go. So you can see how it's arranged on the print bed. We're actually going to be printing it the wrong way, and you can see the red, meaning that the slicer knows that that wouldn't print correctly. So what we want to do is take it and rotate it. We're going to rotate it a full 180 degrees around to there, and there we have it. Now it's sitting the correct way to print it. I am going to push it just a little bit closer to the front of the print bed because I believe it will print a little bit better. And then we're going to adjust some of our settings. So with the bottom part, you saw that it was a little bit warped. So we are going to, because it's a little bit of cooler day today, we're going to take this temperature. Let's take it up to about 107. We'll try to decrease the amount of warping that will happen on this lid. That is something that happens as you print large objects, large stretches of distance. It tends to warp, and you saw it only warped the first centimeter of the corner, but still a problem. So in order to also help with, there was a slight defect because my print bed is a little older and a little bumpy, so I'm going to print let's see, I think 5 top layers is good, but let's print about 6 bottom layers. So the bottom layer is the part that will show once this is put together as a box. So I'm basically making the bottom layer as it prints is really the top layer of the finished product. So I'm making that a little thicker. As a matter of fact, let's make it 7, and we'll leave everything else the same. Everything else looked good. The top layers, in other words, the inside of the lid, will be fine. That's 5 is fine. But I want a couple extra layers at the bottom to reinforce the actual surface on the top. Leave everything else the same, and we'll slice it. Okay, so let's preview that. Get rid of these settings. Now, as we zoom in, again, you can see all the walls, 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 walls. As we get to the bottom, if we zoom in close to the corner, because that will allow us to see what's going on. Let's zoom in really close to the corner so you can see these paths. Okay, so now as I go first layer, second layer, third layer, fourth layer, fifth layer, sixth layer, 7 layers on the bottom, then it starts infill, infill, infill. And still we have 4 walls on the sides. And then here you can see it's starting the inner surface, and it's going inner, inner, inner. And then now that's the inner wall, inner wall, inner wall. And then it makes the full wall. So very cool. Okay, now we're going to save it to disk, and I will send it to the printer, and we will do it. And I'm going to mention that this is the lid, so that when we print it, we know we're printing the lid. Get back into our web browser. So here we see our interface, temperature, levels, and the webcam should come up here. Let's go to upload. Upload. We'll choose the model that we just created. That's lid, created just now. And here we go. It's uploading, refreshing, and there it is. So let's print it. You can see here again, it prints the perimeter first and then the diagonal main surface, followed by perpendicular diagonals on the next layer, and then perpendicular again, and then perpendicular again. Remember, we printed 7 bottom layers. And here's the infill, and then the inner layers. Very rough, then smoother, then smoother, then very smooth. Then walls, walls, walls. This lid was very well attached to the print surface, so I did actually have to gently heat it a little bit and really work at it to get it to come off of there. Okay, so here's the final product, the box and the lid. And you can see it fits together very nicely. Just a tiny bit of a gap, 1 millimeter all the way around. Okay, thanks for joining me. Don't forget to like and subscribe and share with your friends. Have a super fun hobby #1 day.